Imagine a situation where you have an Arduino which needs to be interfaced to a 3.3 volt sensor, which takes 5 milliamps. All you have is 5 volt output from Arduino. What is the easiest way out? You can use an expensive and difficult to fit low dropout voltage regulator, but are there any cheaper alternates? One solution is to use 3.3 volt Zener as cheap and easy to fit regulator. We need to calculate series resistance R. We need to calculate the total current which is composed of Zener bias current, sensor load current. Always remember, Zener diodes are used in conjunction with series resistance to limit current. Let's consider Vishay Semiconductor BZX55 series small signal Zener diodes. They have low Zener bias current and hence low consumption. Very important. They have sharp reverse voltage characteristics, also important. We shall pick the 3.3 volt Zener out of this series. It only has 5 milliamp bias current. So now we have picked a Zener diode of 3.3 volts and 5 milliamp bias current. Let's do the series resistance calculations. Zener current and load current is identical, 5 milliamps. Total Zener current is 10 milliamps. Series resistance comes out to be 170 ohms. An easier to find standard resistance is 160 ohms, which can be used. Now that we have designed the circuit, let's look into some consideration. Zener diode is an inexpensive and easy way to regulate voltage. Zener regulation is not very accurate. If you need accurate regulation, look for other solutions. Most importantly, Zener diode consumes extra power in form of bias current. Consequently, it may heat up if not biased accurately. Your support is vital. Please don't forget to like and subscribe.